Assalamualaikum. My name is Nur Alisa Sofia binti Maswari and my metric number is CD240284. A particle is a point mass. This means the mass is concentrated at a single point and the particle has neither dimension, height, weight, and more, nor orientation. Angular position. This condition of equilibrium are expressed through the equation summation fx equal to 0, summation fy equal to 0, and summation fz equal to 0 for force in different directions. The separation of force into components and their balance are critical to solving static problems, which have practical applications in fields such as structure, engineering, mechanical system, and force analysis, ensuring that systems such as building, bridge, and machines remain stable and function properly under applied loads. This is about substitution a single force with the same impact as the original force for two or more forces operating on a particular particle. The outcome of the initial force acting on the particle is this one equivalent force. Eventually, some of the forces operating on a particle will be identified by deriving the relations between the different forces acting on the particle in an equilibrium condition. The word particle is not used to suggest that our research will only focus on little corpuscle. This means that all of the forces acting on a particular entity will be taken to be applied at the same place, and the size and shape of the bodies under discussion will not have a substantial impact on the solution of the issue covered in this chapter. You will be able to tackle several technical challenges in this chapter, such as assumption is validated in several real-world applications. The study of force and cause in a single plane takes up the first portion of the chapter, while the analysis of force in three dimensions takes up the second. For the literature review, a fundamental component of classical mechanics and engineering, the study of particle statics offers fundamental ideas for comprehending and evaluating equilibrium system. Newton's first law of motion, which states that everything at rest will stay at rest until acted upon by an external force, is the foundation of the idea. In practical research, the concept of particle statics have been used in domains like structural engineering, where they are essential for creating load-bearing structure like trusses and bridges, as well as stable frame. In order to guarantee stability, studies have also shown how statics may be used to predict tension and stress distribution in cable and suspension systems. The formula for the statics of particles are derived from the condition of equilibrium, which state that the net force acting on a particle must be zero. These are typically applied in two-dimensional 2D or three-dimensional 3D system. The first one is equilibrium condition. For a particle to be in equilibrium, summation F equal to 0. This means the resultant of all force acting on a particle is 0. The second one is equation of equilibrium in 2D. In a two-dimensional system, the force get resolved into horizontal X and vertical Y components. For equilibrium, summation Fx equal to 0, summation Fy equal to 0. 3. Vector form. For simplicity, the equilibrium condition can be expressed in vector form, like F1 plus F2 plus should have many force plus many force plus Fn equal to 0. For extension and angles, for particle in system with rock or slope surface, force are frequently evaluated using trigonometric function, resolving a force F into component. Fx equal to F cos theta, Fy equal to F sin theta, where theta is the angle the force makes with the horizontal.
Assalamualaikum, my name is Sofiana Irani binti Sunim. My matrix number is CD240073. Problem definition is the swing consists of a seat suspended by ropes or chains from a fixed support. The swing is assumed to be at rest with no motion occurring in either the horizontal or vertical direction. The ropes or chains are considered to be inextensible, do not stretch, and massless, while the seat has a constant weight due to its mass. Can find force, tension, or torque. It depends on the question.
Hi, Assalamualaikum. My name is Amri Zulaikha binti Aziz and my metric number is 240146. So now I will talk about mathematical modeling. A child sitting on swing of mass m 20 kilo is pulled back by the horizontal rope until the swing make an angle of 45 with the vertical. Assuming the swing is in static equilibrium, calculate it. So first we need to calculate the tension T1 in the rope supporting the swing. It's diagonal rope. And we need to find the tension T2 in the horizontal rope used to hold the swing in place. As we already know, gravity is 9.8 meter per second square. First, let's analyze the forces. Weight equal to mass multiply gravity. As already given in equation, mass is 20 and gravity is 9.8, so we got 196 Newton. T1 is the tension in the diagonal rope and T2 is the tension in the horizontal rope. T1 sines 45 degree equal to T2 and T1 cos 45 degree equal to weight. So first, let's find T1. T1 cos 45 degree equal to weight. T1 multiply 0.707 equal to 196. And T1 we got 277.23 Newton. So now we already got T1 and let's find T2. T2 equal to T1 sines 45 degree. T2 equal to 277.23 Newton multiply 0.707 and we got T2 equal to 196 Newton. So the final answer is T1 equal to 277.23 Newton and for T2 equal to 196 Newton.
Hi, Assalamualaikum. My name is Ahmad Amirul Shahwan bin Azhar and my metric number is CD240303. Result. Force balance is essential for maintaining the stability and equilibrium of swing. The vertical tension in the diagonal rope balance the child weight, while the horizontal rope counter the horizontal tension, keeping the swing stationary. The principle is crucial in real-world application, especially in the design and engineering of playground equipment, where the accurate force calculations are necessary to ensure both safety and structural integrity.
Assalamualaikum. My name is Anis Akila binti Zamzuri. My metric number is CD240278. Now I will present about discussion. The challenge of calculating force on a swing is an excellent example of how physics ideas, particularly static equilibrium, may be used in real-world situations. This arrangement highlights how important it is to understand how a system forces are balanced to ensure its stability. The tension in the vertical component of the diagonal rope precisely balances the child's weight, while the tension in the horizontal component of the rope counteracts the horizontal component, preventing the swing from moving. Equilibrium prevents motion in all directions, as this force balance illustrates. In practical applications, such as designing playground equipment, this calculation ensures both functionality and safety. For example, ropes and material must be chosen to withstand the calculated tension without breaking or deforming. Furthermore, understanding such force can guide engineers in designing more efficient and secure systems, taking into account the different loads and angles at which force might act. Beyond playground, this principle extends to many structural and mechanical systems, emph- emphasizing the universal relevance of static equilibrium in engineering everything.
Conclusion for this case study: ensuring that a swing is in static equilibrium is essential for both its design and safety. When the swing is at rest, the forces acting on it, such as the weight of the seat and the tension in the ropes, must be perfectly balanced in both the vertical and horizontal direction. This state of equilibrium ensures that the swing remains stationary, preventing any unwanted motion when not in use. We can accurately calculate the tension in the rope and verify that the swing is structurally sound. This analysis is critical for the safety and stability of the swing in playgrounds and recreational areas, as it helps avoid accidents resulting from instability or failure of the swing. A swing designed with static equilibrium in mind ensures that not only safety and durability but also comfort for user. Thank you.